So to start today's lesson, I'm going to have you guys fill out this chart real quick, which is going to help us throughout the next 3 days when I'm going to be asking you to find roots other than square roots. So the way you fill out this chart is you're going to take each x value that's all the way to the left and raise it to the power listed across all the way on top. The boxes that are shaded, you do not have to fill out. The whole top row is all going to be 1 because 1 to any power is always 1. So then you're going to take 2 and you're going to do 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, etc., all the way down the line. So you're going to do that with each of those numbers and just take the next minute or so. You can use a calculator and raise each of those x values to the indicated power. Later in today's lesson, I'm going to show you guys how we're going to use this chart. When this chart is completed, we're going to spend around 20 minutes of class time today going over last night's homework. It was on the longer side. You were able to work on it in class, but you also had to finish a lot for homework. So I want to go over some of those, especially the ones that were more Algebra 2-like and the SAT questions. Okay, so I'm going to have you guys hit pause, fill out your chart, spend 20 minutes going over the homework, and then come back to the video and we'll move on to the next part of the lesson. So the next part of the lesson, after you guys did those two things, is to talk about radicals and roots and the different forms that they come in. So our goal today in this section, which is still the first section of Unit 3, is to simplify rational exponents. All right, so that is our objective, that is our goal. If you think about the word rational, the word rational has the word ratio in it, and ratio is referring to fraction, comparison of two numbers. So the expressions that we're going to be working with for the rest of the week are going to have fractions in their exponents. So the notation that you're going to see that in is in two forms. You can see it in radical notation or in rational exponent notation. So this is called the nth root of a. It'll look like this. Okay, this is radical notation. And would be called the nth root of a. Okay, so instead of just dealing with square roots, we're going to be working with cube roots and fourth roots and fifth roots and higher roots. The other way you can write this, that would mean the same thing, but in rational exponent notation, would be a to the 1 over n. So this would be rational exponent notation. We did see this towards the beginning of the school year when we were talking about domain restrictions, just to show you something that we did see already. We talked about how the square root of x is the same thing as x to the 1/2. So we saw that back in September when we were talking about how even roots having a domain restriction, how the x to the 1/2 is an even root, it's a square root, but in a notation that you're not as familiar with. So that's just a connection that you would have seen earlier this year. So we're going to be working with more of that rational exponent notation. Sometimes the numerator is not always going to be a 1, so I could also give it to you in this format. So if I had nth root of a to the m. If we were to rewrite this into rational exponent notation, we could use our properties of exponents by rewriting it as an exponent and using some of those properties. So this would become a to the 1 over n, okay, just like we talked about before. The nth root of a is the same as a to the 1 over n, but that's still to the m power. Power to a power rule says you multiply the powers, so this will become a to the m over n. So it's just using the two forms that you might see it in. Also, sometimes in that original radical notation, you could also see it as the nth root of a to the m with the m underneath the radical. That would also be equivalent, another way that you could see it. When we're working with these, the denominator, I will always refer to as the root of the problem, so what root you were taking. And after you take the root, you will then raise it to the numerator, which I will refer to as the power part. So power over root. Power over root. Okay. So I could ask you to find something like this, 64 to the 1/2. That really means, if we focus on the root, take the square root of 64. This is the same thing as take the square root of 64, which would be 8. When we use some of the other properties throughout the week, the properties of exponents are going to come more into play, especially when we have negative exponents. We have to remember that means we have to move it to the denominator. Those will come up as we do some examples later today. But first, I'm going to show you how we're going to use that chart that you guys filled out. So I'm going to pull that up here. Mine's not completely filled out yet, so let me just fill in a couple more numbers. I'm not going to do it all out right now. 927, 81, 243. Do a couple more. Sorry about this. You guys probably should have hit pause. We're wasting time. All right, I'll stop there. So the way we're going to use this chart is backwards. And I wish I could have like a split screen right now. So I'm going to kind of write small at the top of this. I'm going to ask you questions like, let's find the 5th root of 32. And I could give it to you in radical notation or in rational exponent notation. So if I were to use the chart, we're going to use it backwards. So this is a 5th root. That 5 probably should have been a little tinier. So I'm going to go to the x to the 5th column and locate 32, and then look all the way back to the left. That means the 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 32. And when you're rooting a number, you're trying to ask yourself what number times itself that many times would give you the radicand, or the number underneath. So this is going to equal 2. I could also ask you it in rational exponent notation. So I could ask you to find 216 to the 1/3. Okay, this means find the 3rd root of 216. So you would go to the x cubed column, look down until you find 216, and look all the way over to the left. So the cube root of 216 is 6. So the first column, and you guys should be familiar with, okay, the x squared column, you should know all your perfect squares. So what you're going to be asked to do over the next few days is to study and memorize the other numbers. So we have to become familiar with perfect cubes, perfect fourths, and perfect fifths. So in middle school and in probably in geometry a little bit, you had your perfect squares memorized. You're going to have to study, practice, quiz yourself, and memorize these other ones. When it comes time to take the quiz or the test, it will be a no calculator and no chart quiz. So you have to have these memorized. If I ask you the 4th root of 625, you need to know that that's 5. So the long-term sub, she can show you the ring that I have made, which has a bunch of flashcards on it. And on one side, I would write, say, the 5th root of 32, but I would also write it as 32 to the 1/5. So you would see it in both forms. And on the back, it would say 2. That way you can quiz yourself over and over and over again until you have these numbers memorized. The more you practice them, the more, or the quicker you're going to get at using them. Okay, so that's a very important chart. Going back to the examples that we're going to do today, We only have a few since you guys spend a lot of time going over homework. We're going to do 4 of them. For all of these examples, we are going to first rewrite it, just practice rewriting it in both notations. And then we are going to go ahead and simplify it down. And obviously today's day 1, so definitely use those charts as you start to get familiar with the different roots. So first one, 32 to the 4/5. This is given to us in rational exponent notation. So the first thing I'm going to do is just practice rewriting it in the other notation, which would be radical notation. You're going to look at what root it is. What is the root in this problem? It is 5. So that's going to be the index of the radical. It's going to be the 5th root of 32. And then that will be raised to the 4th power. So the power goes outside. So that was just rewriting it from rational exponent into radical notation. Now we're actually going to do it. So let me explain how we do it. You do the root first, which is the 5. You can use your yellow chart, or usually I photocopy them in yellow, but whatever color charts you have. You can look at that chart and locate the 5th root of 32. We did that earlier. I pull that up again. Okay, 5th root of 32 was 2. I'm going to write that down. 5th root of 32 becomes 2, but I still have this power of 4. So that's going to become 2 to the 4th, and when you do that out, you will get 16. So just to restate, 5th root of 32 is 2, raised to the 4th power becomes 16. So you do root, then power. When you're evaluating these, you do the root first, and then raise it to the power. Denominator, then numerator. Next example, so we're going to have the 5th root of 243 cubed. This time it's given to us in radical notation, so we're going to practice rewriting it in rational exponent notation. Okay, you can hit pause, you can try it on your own first, and then check to see your answer with my answer. We're going to get 243. The root is the denominator, so 5 is the denominator, and the power is the numerator. So it's going to be the 3/5. When I evaluate these, we're going to go ahead and do the root, then the power. So 5th root of 243, we look at our chart. Okay, X to the 5th column, locate 243, look over, and the answer is 3. So the 5th root of 243 is 3, which we are then going to cube to get 27. Number 3, 256 to the negative 3/4. Pause, go ahead, rewrite that in radical notation and see if you can go ahead and evaluate that. This is going to use the properties of exponents a little bit because of that negative. So when I rewrite it, root comes first, 4th root of 256 to the negative 3rd. If we look at our chart, I'm going to do root, then power. So 4th root, 256 is 4. So back over here, 4th root of 256 is 4 to the negative 3rd. And now, because it's a negative exponent, it's going to move to the denominator. We're going to get 1 over 4 to the positive 3rd, which is 1 over 64. Notice I did out the root before I moved it to the denominator. You could move it to the denominator first and then do out the root. But I think it's easier to do root than power. Also, when the negative is in the middle, always put the negative with the numerator. You cannot have a negative denominator, a negative root. So make sure the negative stays up top. And the last one for today, we're going to have 8 over 27 to the negative 2/3. All right, this one we're going to skip rewriting in radical form, and we're just going to go ahead and try to evaluate it. Because as a fraction and its division, we are allowed to distribute the negative 2/3 to the numerator, 2/3, and denominator separately. Okay, so we're allowed to distribute that. From here, I could either do the root or I could flip it. Doesn't matter which one, you'll get the same answer in the end. We're going to take the roots. So see if you guys could take a second, pause, and try to find the third root of each base. Third root of 8, third root of 27. When I do that, third root of 8 is 2 to the negative second, and the denominator, third root of 27, is 3 to the negative second. I'm going to flip it because they're both negative to get rid of the negative exponents. And because these bases are different, the 3 and the 2, I can't do any canceling. I have to just do out the powers. So I will get 9/4 for a final answer. So your homework tonight, you don't have to do the entire worksheet. You're just going to be doing questions 1 through 12. It's going to be kind of broken up over the next few days. So you're going to apply these ideas of roots and rational exponents to questions 1 through 12. Tomorrow we're going to do more practice. I'll also show you how to do these on the calculator. And then we're going to start to get into, well, how do we simplify them if they're not numbers on our chart? Okay, so we'll pick up from here tomorrow.